Section 8.6 talks about loans. We are going to calculate monthly payments, how much something would cost if we borrowed a certain amount, how much interest we would pay over the life of the loan. A couple cases we're going to look at today are car loans, home mortgages. One we're not going to look at, but is often the case, is college or student loan debt, and credit cards. We're going to look at credit cards later on. So in the first example, we consider a house with a $100,000 mortgage with an annual rate of 6%. We're going to base our stuff today, though, on a monthly rate. Our equations are going to use monthly information because it's paid back monthly. We're going to use the formula we used before. The final amount A is equal to the principal, and then 1 plus the rate and raised to the time. So what is the interest paid in the first month? Well, our principal is $100,000. And then I have 1 plus our rate, which is 0.5%. So as a decimal, that is 0.005. And we want to know after 1 month, so we're going to raise that to the first power. When we calculate this, after 1 month, we would owe $100,500. So everything over $100,000 is the interest we would kind of accumulate over the first month. So we would have $500 in interest after only the first month. So that leads us to the next part. If $500 is paid after 1 month, how much is owed after the first month? Well, if we pay $500 and we've accumulated $500 interest, essentially they're offsetting each other, so we still have to pay $100,000. So what needs to happen with loans is you have to pay more than your interest accumulated. So after 1 month, adding up our loan plus our interest, we have $100,500, and then we're going to take away $1,100. So essentially we made then a profit of $600, or we're paying off $600. We've had $500 in cost and interest, paid off $1,100. So that would leave our total loan amount after the first month at $99,400. So here's our formula that we're going to use today. We have a principal, that's the amount we're going to borrow, an interest rate, that's the percentage of the borrowed money that the borrower is charged by the lender. In order to borrow money, you have to pay them to borrow their money. And then the term is the length of time. This information, especially the interest rate and the term, today we're going to base on months. So if they give you an annual rate, divide by 12 to get the monthly rate. And as you can see in our formula here, here's a formula we have to pay back a loan. And a couple of things, notice it's N equal installments and at a rate of R per installment. The rate is based on per installment. That's why R is going to be a rate, a monthly interest rate, and N is going to be then the number of months. So it's going to be the principal times 1 plus the interest rate raised to the n power times the interest rate divided by 1 plus the rate raised to the number of months minus 1. So let's look at this information put all together. So Mr. Big Spender borrows $13,000 at 7.75% interest to be paid back in 42 monthly installments. So the term of his loan is 42 months. That's how long it's going to take him to pay the $13,000 off. The principal is $13,000, and the monthly interest rate is the 7.75 divided by 12, which gives us a rate of 0.6458% per month, and that is 7.75 divided by 12. Now if we look at Mr. Big Spender's monthly payment using our formula, principal is $13,000, and then we have the 1 plus the rate, and we have to make sure that we use the monthly interest rate, and that's raised to n the number of months, 42, times then our interest rate, which is 0.006458. All of this is divided by the 1 plus r to the n. Notice our formula again uses the 1 plus r to the n, which is the exact same as above. And we're going to use that fact in our calculations in 1 second. So there we're just plugging numbers into our formula. So let's now take a look at that and plug those in. So the one thing, based on the fact that both of them have 1 plus r to the n, what we're going to do is figure out what 1 plus r to the n is. So 1.006458, and we're going to raise that to the 42nd power. Now that number shows up in our numerator and denominator. So to calculate our numerator, it's going to be 13,000 times the 1 plus r to the n. But we have that number. That's the answer to the previous calculation we've done. And we need to multiply it by the interest rate, 0.006458. We need to divide that by 1 plus r to the n. So that's our previous answer again. So you see how by calculating it up in the top here in the first calculation, it saves us a little bit on the bottom, and then minus 1. So that gives us then our monthly payment of $354.39. So here we have $354.39. That's our monthly payment. Now, how much money will the bank make off this loan? Well, if we do 42 months times the $354.39, we get a total of $14,889.38. If we take away what we actually borrowed, the $13,000, that gives us a grand total of, we paid an extra $1,889.38. So we paid an extra $1,889.38. That means the bank made $1,889.38 off Mr. Big Spender's loan. Mr. Oh No wishes to borrow $23,000 to buy a new car. So his bank has two options. Option A, which is a loan for 36 months, is 3.4%. And loan B is 48 months at 3.9%. So how much smaller will a payment be? Right, so we need to calculate the payments for each of these. So let's start with loan A. If we need to know how much bigger B is, we need to know how much A is to start with. Using our formula, the original amount is $23,000. 1 plus our interest rate. If we do our interest rate on loan A, it's 3.4 divided by 12, which is 0.00283. So as a percent, that's 0.283%. And it's 36 months times our interest rate, it's 0.00283. And this is all divided by the 1 plus r to the n again. Let's write out the equation then for loan B. It's 23,000 still. 1 plus now the interest rate 3.9 divided by 12. If we change that to a percent, 0.00325. And that is going to be raised to the 48 for the number of months times our interest rate, all divided by the 1 plus r to the n minus 1. Now let me give you these numbers. You would calculate them the same way we did in example 2. So loan A would have a monthly payment of $672.89. Loan B would have a monthly payment of $518.29. So how much cheaper is it? To calculate that, we take this $672.89 minus the $518.29, and that means that loan B would then be $154.29 cheaper. Well, option B is then the logical choice because it's cheaper, but remember it's 12 months or 1 year longer. So let's look at maybe a more important question: how much interest would Mr. Oh no pay in interest, right? How much total, right? How much more interest for option B? It sounds cheaper. Let's look at how much he would pay then. Well, if his monthly payment for option A is $672.89, he needs to multiply that by 36 to get the number of months. And in option B, we need to take the $518.29 and multiply that by 48. When we do that and subtract the amount, so in option A we get a total of $24,224.04, and therefore that means we paid interest of $1,224.04. In option B, we would pay $877.92, thus leaving a grand total of interest here of $1,877.92. So now if we find the difference between those, we pay definitely more interest here. $1,877.92 minus $1,224.04 means that loan A is cheaper in the long run, $653.88. Right? So it's more than just the monthly payment, it's the interest over the life of the loan.